Good afternoon, everybody. Today, first of all, I'm sorry for not streaming the yesterday and the day before. Unfortunately, real life had to take over. But, fortunately, now we're able to do a big, long stream today. And hopefully we're going to make a huge dent in this tutorial. So we're currently on part 8. We did parts 1 to 7 over the previous few days. We're now on part 8. We're adding our ammo pickups and consumables. You'll notice in the previous stream we did the UI, UI widgets for them. Now we're actually putting in the pickups themselves. So let me just move my mic a bit. There we go. So, if we successfully made it to this part of the tutorial, as soon as we have a basic map, movable character, and a game GUI. So, we're going to be adding pickups to the game, as I said. Health and stamina, as well as ammo, and we'll be updating the GUI values when blah blah blah. So, instead of creating separate pickup items for each of them, we're going to create a base scene for the pickups that we can reuse and then via enums and export. So, we're going to be learning about our inheritance, which is, I suppose it's inheritance is where the men from the boys get separated. At least that's how it was back in uni, in Java. So let's create a new scene with an area 2D node as root. So we want a new scene. I still don't know why Godot's usually so unresponsive, but so we want an area 2D. This thing. An area 2D serves a node that will detect collisions, so we can use this area to detect if the player scene has entered this body via collisions. And you can see there's nothing on this at the moment because there's no shape. We can rename the area 2D node to pickup and save it underneath the scenes folder. Oh, god damn it. So we'll notice that the water node has a warning next to it because it needs a shape to actually detect stuff. So get rid of this to be add a collision 2D node. Collision shape 2D node, I should say. And we want to give it a sprite as well. Before we select the shape, let's give it a sprite so we can see what images is before we give it the collisions bounds. Add a sprite 2D node, assign any icon from my assets icons folder. So wait, yeah, no, the sprites in here. It's icons that I want. Yeah, assets icons. Let's see. Chance 01E, yeah, we'll have that. Now let's assign a shape to the collision 2D node, make it a new rectangle shape 2D. And drag the bounds of the collision shapes to frame our icon. Fortunately, no, it snaps to pixels. That's good. So the pickup will serve as the base scene for all of our pickups. From here we want to be able to dynamically choose the pickup type and add to our player's inventory whenever they run over it to pick it up. To do this, we'll need to attach the script to the root node of our pickup scene and save it underneath scripts. So we'll close this. Oh yeah, here we go. Pickup. Add a script. We'll call it pickup. Should inherit from 2D no templates. Here we go. While we're here, we'll save it. Oh. No matter. I think it just automatically puts it in the same place as the scene. Where are we? Pickup. At the top of the script, let's create an enum for all of our pickup items. We'll export this enum so that we can dynamically choose the type of pickup we want to place down from the inspector panel or editor. Enums are shorthand for constants and are basically stand-ins for integers. To create enums, we use keyword enum followed by the constants in the brackets. Ammo, stamina, health. And we'll want to expose it to the editor and declare a type of pickups or enum objects, whatever you call it, enum field. Now if we look in our inspector panel, we can choose the pickup item from our drop down. So let's go up to, not here, but here. 2D, there we go, and I'll pick up. I think I would hope if I saved it, that might do the trick. Oh, here we go. Item, ammo, stamina, health. And it automatically does the casing, whatever you call it. So next we want to also choose its icon or texture, because not all of our pickup items look like diamonds, so I chose something else, and yeah, that's not a diamond. To do this, we will make use of something new so that we can see real-time changes to our textures now. So we use @tool, which is a powerful line of code that, when added to the top of the script, makes it execute in the editor. You can also decide which parts of the script execute in the editor, which in-game, and which in both. So this would be running editor, this is normal, and this is execute always C# attributes in Unity. So let's do it. Let's put it to the top of our script. Tool. Before our extends, then we need to assign our textures. So for each of our pickups, we will preload our textures. Preloading is when resources are loaded before a scene is playing or running. We preload our resources to speed up loading and reduce freezing since resources are already loaded. Let's assign the textures that we use for our GUI icons to each of our pickup items. We should be switching to this browser window by an actual click rather than looking on the monitor. Right. So, bar, ammo, texture, is preload. There's assets icons, and we want shard 01i. I think it might have been easier to just type it out. And then we do the same for ammo and stamina. Not ammo and stamina, health and stamina. So this is a potion 02B ping, and this is potion 02C. Potion 02C.ping. Got a health texture instead. Since we want to constantly check whether or not these sprite frames are changing when we assign new pickups, we want to add the conditional check to change these textures in our process function. We used this function before when we implemented our custom signals. So we want to execute our conditional in the editor to see our texture changes in the editor without having to run the game. To do this, we will use our tool functionality, which requires the engine.isEditorHint function to run the code in the editor. So let's go back to our editor, and underneath here we can implement process. So it says if engine dot is editable. So I think this is equivalent to the preprocessor in Unity if Unity editor. Yeah, preprocessor things are a bit of a weird thing in C#. So executes code in the editor without running the game if it's not running. So if item equals 2 equals pickups dot ammo, then get component sprite 2D, set texture, ammo texture. Else if item equals pickups.health, and then we'll set the texture to health. Come on, editor. Health texture. Do the same for stamina. Does GDScript have switch statements? Well, Python doesn't, so I'm guessing GDScript doesn't. So if we instance our pickup scene in the main scene and you change the pickup item in your inspector panel, the texture should change. So let's save this. Go to our main scene, into 2D, and we instantiate ourselves a pickup. Let's pick up here, and then we can change it, and yes, it does what it says on the tin. We also had to reflect these settings in game, so for that we will set our textures in the ready function. So back to pickup. If not, episode. Setting this every frame. So now it's... Wait. Save it. Then... Yeah, it doesn't do that, but when we do play it, you see it's changed to health. And it's... Wait, did it change to... Oh, it does change like that. There's no logic for picking it up, but oh. Right. If you instance multiple pickups in your same change that you will now see the changed in game as well. If your player run through the pickups want to remove them from our scene and add them to our player's inventory, we'll have to make use of some custom signals and functions to make this work in our player's script. But first, let's focus on removing the items from the scene when the player collides with it. The area 2D node comes with a built-in signal called body enter, which emits when a defined body enters the area. This defined body is any body that has a collision shape added to it, just like our character body 2D from our player scene. So, go to pick up, script. Okay. Connect signal. Right, how do I do this? It's body entered. Connected to pickup. There we go. Let's see, it creates a new function on body entered. This thing at the end of our script. In the new signal function, we will want to check if the body that entered our area is called player, and if so, our pickup scene should delete itself from our main scene tree. When a node is part of a scene tree, the tree can be obtained by calling the getTree method. To remove a node from the scene tree, we can either use queue_free or queue_delete. So let's add this code. If body.name is player, and then they put in a to do. Tree queue_delete. So don't think we need to get rid of the past, but might as well. Run the scene and have the player run through the pickup items that should be removed from the scene completely. So we'll save this. Run our, not our pickup scene, but our main scene. You go here, and it disappears. We'll see in the code sample. We added the line 2 or to do adding function from here. We'll first need to create the function that will add these items to our player's inventory from the player script and then reference it in our pickup script. Player's inventory won't be a traditional one that we can add many items and objects to, but with an invisible one that will only be shown for our pre-existing GUI. In other words, our inventory will only be able to contain pickup items. In our player script, let's define some more signals to update our pickup items values. These signals will emit whenever we remove or add a pickup item. So go to player, and before extends code, divi on our custom signals, let's add signal ammo pickups updated. Bish bosh, and then we can add health and stamina pickups updated. We'll also need to define our pickup scene again so that we can use the same constants. So No, don't the scenes, the scripts. So it would be here. Okay. So I'm guessing you can't access enums from other classes, or I don't know. We'll get there. We'll get there when we get there, I suppose. Ammo. Pick up. I cannot type today. Equals 0. Health. Stamina. So with our variables, enum and signals defined, we can go ahead and initialize our signals in our ready function. Initializes the pickup signal to update their values. Arrow pickups, emit, and okay. We just copy paste this code. Ah. Finally, we can go ahead and create our own custom function that will add the pickups to our player's inventory in the GUI in the top left of the screen. We'll call this function in our pickups script so that we can pass the item variable into our parameter, as that is what we will choose in our inspector panel. We will do a conditional to check which item has been picked up, and then add X amount of that item to our player. We will also need to emit our signals to notify the game that the value of our variables has changed. So we'll probably add it at the bottom. Add pickup. If item is pickups ammo, then ammo pickup equals ammo pickup plus 3. Ammo pickups updated dot init ammo pickup. Print ammo val plus str ammo pickup. So far, so Python. I think these should be ellipse, but they say if in the original code. I suppose, you know, only one of these is going to be true at any given time, so I don't think it'll matter in the grand scheme of things. So we ammo pickup. And then we replace with health pickup. Selection only. And replace all in selection only. That's a good. That's a very good. That's a very good feature. We'll get alternatives to 1 as well. Same with this. Instead it is stamina. Boop. There we go. Now we can go back to our pickup script and reference the function via the body method to add that item. So we'll save here. So it would be body dot add pickup. So we are using Python rules, so it won't throw a wobbly if it's, well, it won't throw a wobbly at compile time, but it will at runtime if this add pickup doesn't exist. Okay. We can add print functions to our add pickup code to see if this function will run the game and have our player run through our pickup items. I think that's already been done. Let me triple check. Yes. Okay, we'll save all of these. Now let me finish the tea. So our pickup items now get added to our player's inventory, but we do not see a change in our GUI yet. We'll add it now so that our changes can be reflected in the game and not at the console. In our main scene, add a script to each of our UI nodes called ammo amount, health amount, and stamina amount. Save them underneath our GUI folder. Oh, the GUI folder. Okay. Right. So our main scene. Add scripts to each of these. It should, yeah, it does inherit color rect. Ammo, health. Yeah, so put it in GUI. And stamina amount as well. Let's have 3 of them. Just like with the scripts for our health bar and stamina bar elements, we will create a function that will update its value via the connected signal in the main script. Health amount, stamina amount are going to be confusing. It probably should be health drink amount, stamina drink amount, but whatever. Not my tutorial. Just like the scripts for the health bar, we'll create a function that will update its value. So was it? Oh yes. That's on ready. Var value equals dollar value. Function. Update ammo pickup. Update ammo pickup. There's an underscore there, not space. Value dot text. Equals str ammo pickup. And then we add something similar to our health amount and stamina amount. So, no wrong file, but oh well. Easy fix. Amount, and it saves us from having to do this thing again for the ammo thing. There we go. So now let's hook them all up in main. Yes. Let's copy paste. There we go. Now if I run our scene and have a player run through our pickups, our GUI should update. So let's... whoa. Don't want to save that, I want to save... yeah. Hang on a sec. No, that's okay. This village you can fuck off. There we go. Yeah, I thought I'd opened up my entire file system, but no, the only thing there is that I'm using an Acer laptop, which is not exactly the most identifying information. Where were we? Oh yes, we were adding different kinds of pickup to our scenes. So what's our ammo here? We'll duplicate it, so we'll have this one, I don't know, here. Stamina. This one about here. Health. And this one over here, and we'll keep your ammo. And if we run our game, they've updated. As you can see here, it's updating our inventory, or rather it's updating our GUI. I think the actual inventory class will update later, and of course we still have infinite ammo. It's got a bug where it's firing normally. Whatever. We'll get there. So let's create two new input actions called UI consume health and UI consume stamina, and assign input keys to them. I used 1 and 2, but assign whatever keys you feel comfortable with. Okay. UI consume health. UI consume stamina. Lowercase that. So health shall be number 1, and consume stamina will be number 2. In our player script, in our input event function, let's create new conditionals for these input actions. If we have pickups and our health or stamina value on our progress bar is low, we want to deduct 1 from our pickups amount when our player presses 1 or 2 to consume either a health or a stamina drink. Drinking these consumables will restore 50 points of the total 100 points assigned. After our health or stamina has been added to and a pickup has been removed, we will need to then emit our signals accordingly. Our code shall look like this for now. So, player script, it's on input. So, if event is action pressed, attack equals that. If it's second and press to implement a spread to be displayed, then oh. Let me see if this thing. Where's the attack? Down. Oh. Sorry, I thought this was because this animated strategy would be set to loop, but apparently that's not the case. If it's not playing and we're attacking false. Huh? Whatever. So use health consumable. Actually, no, we'll type it out ourselves. Else if event is action pressed. UI consume health. If health is greater than 0 and health pickup is also greater than 0, health pickup equals health pickup -1. Health equals min of health plus 50 max health. Health updated emit, yeah. I think it would, if it was up to me, I'd make my own method called update health, and then it would handle all of those 2 lines of them, because I reckon that we'll be doing these 2 lines of code. We'll be repeating these a lot, but I don't know, perhaps gets addressed in a later tutorial, so I don't want to jump the gun. So we want to repeat this for the consumed stamina. Stamina, and then replace health with stamina. If we run our scene now and pick up your stamina pickup sprint and then press 2 to consume. Okay. Right. Oh, the stamina's not been... What's only happening on the sides? Oh, whatever. Okay, so our stamina logic is really wrong. See, yeah. Come on, got it. Yeah, okay, so our idle side is the shooting thing. I don't know how that's happened. I don't know how that's happened at all. Side sheet. What was it, 16 by 5? No, it's 17. No, it's not 17 either. It's 14 by 5. It's these frames. And then we... Hang on, so our attack animation is 6 frames. Let's remove everything from here. 1, 2, 3, 4, 5. Idle up. These. Okay, so yeah, go get rid of this one also. Okay, so that's that fixed. Well, there's something really gone wrong. In the next part, part, we'll get to the fun part of the game. We'll set up our first enemy that will challenge our player in the game. It's going to be a long ride, so remember to save our game project, and I'll see you in the next part, which is part 9. Enemy AI setup. No game can be complete without having some sort of threat or enemy to defeat. In our game, we will have a cactus enemy that spawns on the map at a constant value, meaning that there will never be more or less than X amount of enemies on our map during the game loop. This enemy will damage our player if our player touches it, and will also shoot at our player. Let's get started with our enemy AI. Our enemy scene will have the same structure as our player scene, with a character body 2D as its root node, followed by an animated sprite 2D node and a collision shape 2D node. Therefore, we can just go ahead and duplicate our player scene and rename it to enemy or cactus. I'm only going to have a cactus as my enemy, so I'll call mine the general term enemy. But if you're going to have multiple different enemies, you can create a scene for cactus, bandit, tumbleweed, etc. So, we'll, oh, crap. Where are we? Duplicate the player scene and then rename it enemy or cactus. So, we'll save our player script. We'll duplicate our scene and we'll rename it to enemy. Rename the suit called and get rid of the player script. I've got the hiccups. You should also delete the camp 2D node, since we won't follow this node around, and also disconnect the on animation finished. I see. Your final scene should look like the image below, and it does. And I've clicked on the image again. This enemy scene will have to be constantly monitored to update its behaviour. For example, let's say we want to roam around for 1 minute, and then after that 1 minute we want to stop 30 seconds before redirecting and roaming again. We can use a timer node that will emit its built-in timeout signal after it counts down a specified interval until it reaches 0. Your timer... Oh, okay. So we'll go to our enemy node. Rename this to enemy. We want to add a timer to it. This enemy scene will have to be timeout signal counts down until 0. Well, timer has 2 actions. One shot, it will start with an automatic 0, and auto start. If true, the 12 timer will automatically start when entering the scene tree. We want this timer to start as soon as our game does, because we want it to use it to update our enemy's movements after a certain period of time. Therefore, you need to enable the auto start property in the timer node's inspector panel. Like that. We will come back to this timer node later on when we add functionality for our enemies roaming. For now, let's set up the enemy's animations just like we did for player. We already have all of our animation names set up for our enemy, since they'll be able to do exactly what our player does. We just need to switch out the animation frames. To do this, you need to delete the existing sprites frames in our animations. Do this for all the animations, don't delete the animations themselves. So our animated sprite 2D, it's animation, there we go. So delete all the frames. There's no Master Delete all. Kind of sucks, but well. No. Get rid of these. And these. It's got to be a shortcut to clear, right? Nope. Okay. Oh, wait. So there are no more animations. Yep, got them all. Let's start with our attack down animation. Select the option to add newsroom's sprite sheet, waffle button. There are assets, mobs, cactus. You'll find all of our sprite sheets for the enemy. For our attack down animation, we'll use the cactus front sheet. .ping sheet to create our animation. We count 11 frames horizontally and 4 frames vertically to change our numbers accordingly. For attack down, we will use the frames in the 3rd row. Challenge you now to add the rest of our animations on our own using the table below as a guide. Okie doke. There's gotta be a way to set presets for this. Let's see, where's damage? Front sheet, row 4, first frame. Def is the exact same. That one remembered the preset. Idle down. Front sheets. So what? Why is it? I'm guessing it's only resets if you choose a different sprite sheet. Yes, 2nd row, good. Right, sides now. So if Godot is be able to this by this, I think we'll probably want to put it in as a side idle rather than other things, so that we'll use the same sheet for each one. I don't know. Just saves having to wait. What? No, walk side is this. Yes. Idle side is not these, but these. Now up. Idle up, we want to use the back sheet. Again, 11 by 4. There we go. Attack up we already have. Walk up. Back sheet. There's our walk cycle. So we do have frames for attack down. Yep. Attack side, yep. Attack up, yep. Death, damage and death are the same. Idle down, idle side, and idle. Yeah. Walk down, walk side, walk up. Those are all the same. Good. Now we want to be able to move the enemy around autonomously. For that we'll need to create a few variables that will store our enemy's direction, a new direction after a random amount of time has passed. Instead of making it a set amount that they will wait 1 minute before redirecting, we will randomize this value. We also want our enemy to redirect after colliding with objects. Let's attach a new script to the enemy scene and save it under our scripts folder. Attach it to enemy under scripts, enemy.gd. Yeah, inherits character body, that's the same thing. Our enemy's movement will work similarly to our player's movement, so let's add some familiar variables from our player GD script to capture its movement speed and new direction. We will also need to create a variable that will store its current direction. Extends character body 2D, so export var speed, which is 50. Our direction, which is a vector 2, and a new direction equals vector 2 0 1. Okay. Our direction change when our timer runs out after a randomized countdown. To generate this random countdown value using the random number generator class. As the name says, it's a class for generating pseudo-random numbers. The new method is used to create an object from a class. So here's our code. Var RG equals random number generator dot new var timer is 0. We'll also need to move the enemy towards the player if they spot our player in a certain radius. Let's add a reference to our player's scene. Now that we have defined our variables, we can go ahead and initialize our random number and player reference to our built-in ready function, because we want these objects to be initialized as soon as our enemy scene enters our main scene. Since the enemy scene will also be instanced in the main scene, hence sharing a scene tree with the player scene, we can reference the player node via the getTree root getNode main player. Main is our main scene and start player is the player instance in our main scene. Okay, so on ready, we'll copy paste the comment. Now we function underscore ready player equals getTree root sorry, there's some knocking coming from next door. main.loads main slash player rng.randomize. Cannot find property, okay. Oh, okay. Get use a method. Next, let's add our enemy's movement code. The coding process for our enemy's movement will be similar to that of our players. First, we'll add the code to move them. Then, we simply need to add our timer to redirect our enemy and move them towards the player if they see us. After we've done those things, we'll build on that to change their animations according to their movement direction. In this part, we will add the redirection of movement, but not the animations yet. We'll also add our enemy's movement code in our physics process function, since we put all things related to our node's movement physics in this code. Let's start by adding the functionality for them to move via our move and collide method, just like we did for our player. So I've got enemy GD, order code, func physics process. Right. Still an enemy. Func underscore physics process delta. Our movement is speed by delta I think they're knocking in some, they're hammering in something upstairs, not next door. That's unfortunate. Collision is move and collide. Yeah, unfortunately it's just loud enough that the mic's picking it up. And the wall's on the other side of the pop filter, so that doesn't help it either. But not much I can do about that. So now we need to connect our timer node's timeout signal to our script. The signal will emit when our timer reaches 0. You'll see this create a func on timer timeout function at the end of our script. Node. We'll have our timer on timeout connection. Connect it to enemy. There we go. And yeah, it chucks in on timer timeout at the end of it. In this timeout function, we need to do a few things. First, we need to calculate the player's position relative to our enemy. We can find our player's position returned as a vector 00 value by accessing our node's transform values, position, rotation, and scale. By knowing this, if we can access our player's position by simply saying player.position, and if we wanted their rotation, we could say player.rotation.x and so forth. We can also access our current node's position, enemy node, by simply saying position or self.position. After we get our player position, we need to minus it from our enemy's position to get the player's distance from our enemy. Let's go ahead and get this value. Var player distance equals player dot position minus position. Now, if that distance is within 20 pixels of the enemy, it means that the enemy is close ahead, close enough to the player that it doesn't have to chase them, but it can go ahead and attack or engage with the player. You can make this side value any number, but we're going to go with 20 pixels. So, attack radius, so we can attack. If player distance dot length. Oh yeah, it's a vector, so I'm guessing length is normalized. In which case, it'd be better if it was instead player distance dot square length is greater than less than 20 squared. I mean, that's how you do it in Unity. Because it's squaring something is very easy. However, finding the square root of something is rather difficult. So our new direction equals to that, yep. Player distance dot normalized. If they're within 100 pixels of the enemy and the timer has run out, it means that the enemy is not close enough to attack the player, so they'll have to move towards and start chasing the player. You can make this chase value any number, but I'm going to go with... Excuse me. I'm going to go with 100 pixels. If player distance dot length is greater than or equal to 100 and timer is 0. Direction is player distance dot normalized. Otherwise, if the player is not close to the enemy or not in a chase radius, then our enemy can go about its day and roam randomly. The enemy's direction will be calculated randomly via the vector down rotate method, which will calculate a random angle between 0 to 360 degrees. This direction will change every time the timer runs out. So, put chase radius here. And then we have random roam radius. Okay. So, else if timer is 0, generate random direction. Random direction equals RNG dot randef. Okay. This direction is obtained by rotating vector 2 down by a random angle. If random direction is less than 0.05, stop, else get one of those. Right. If random direction is less than 0.05, else if random direction is less than 0.1. To down, rotate by and F by 2 pi. Finally, we need to use our collider variable from our physics process function to see if our enemy is colliding with our player, as well as add our timer range to randomize from. If they're colliding with our player, the timer needs to be set to 0 to trigger our timeout function so that the enemy will chase us. If they aren't colliding with our player, we need to set our animation. We need to set our timer randomizer value, as well as randomize their direction rotation values so that they can turn around if they collide with other objects. This rotation angle is obtained using the randef range function. This angle has a value between 45 to 90 degrees. You can change these values to make it smoother or sharper if you'd like. Our entire code should look like this. So, append it to the end of our physics process. If collision is null, yeah, I'm gonna be lazy and copy paste it. Oh, of course. That's all. So, random range pi over 4, 45 degrees, pi over 2, 90 degrees. Okay, so I'm guessing everything uses radians, which is good because in Unity, if you used to do a rotation, quaternion, or whatever, sometimes it uses degrees and sometimes it uses radians. And yeah, for the quaternion rotation, it's in degrees, but in I think other things like you're trying to calculate an angle, it expects radians. Maths functions. So yeah, it's right in here, but I'm guessing in Godot it's all radians all the time, which is good if you want to. Well, I don't know, whatever. How would it show the inspector a rotation? Whatever. If you instance your enemy scene in your main scene and you run it, then they should chase you or roam around. And so, we have added an enemy that isn't any threat to us. Our enemy has no animations or any value to it yet, but that will come in the next few parts. In the next section, we'll add the functionality to add animations to our enemy's movement. Luckily, we've already added our animations, so it will be a quick setup to display these animations of our enemy's movement. Remember to save, and we'll see in the next part. Right. I'm going to save. I'm going to do a test to make sure that everything works properly. Yeah. Enemy. There we are. Now, if we start our scene. Oh. Okay. Invalid get. Oh, yeah, of course. There we go. That's our problem. Okay, so now it's roaming, roaming, roaming. Get over here, yes. Right now it should chase me. Please? There we go, now it's chasing me. I'll follow it like that, and and launch it away. I know the stamina thing's balked, but yeah, we go away now, and then it starts chasing me. Yeah. It's not going to die. Well. Right. I'm going to take a quick break. And then I'll be back for part 10 of this tutorial. So that's part 10, animating enemy AI movement. Okay, I shall be right back. Okay, and we're back. So, let's go straight on to part 10, shall we? Animating AI movement. Cowboy emoji. What good is an enemy who just floats around our map as a static image? That just won't do. So let's get to work on implementing our animations so that our enemy can come to life. I also have a surprise for you. We already wrote most of our enemy's animation code. Well, not really, I mean, it's still in the player code, but that means we can go ahead and copy paste over some code that speeds up our development time tremendously. It also screws up our cohesion, but whatever. In your player script, we want to copy two entire functions over to our enemy script. The first one you should copy is your function player animations direction vector 2 function. The second one is our function return direction vector 2 function. We name our player animation function output to enemy animations. Okay, so player, we want player animations and return direction, so we want to take these, whoa, copy and paste, which will screw up the whole. Oh no, it doesn't screw up the, oh wait, yes it does. Oh no, it doesn't. Rename your whatever. So it should look like this. Oh, here we go. It's say that we're getting an error saying that animation has not been defined. That means we need to quickly. Okay. That is me jumping the gun. To activate these animations for our enemy's movement, we'll have to first check if any other animations are playing, such as attack or death animations, and if not, we play them in our physics process function. Once again, we did the same for our player character, so this should not be too confusing for you to understand. Copy the is attacking variable from your player's code. Is underscore attacking equals bots. Then in your physics process function, let's call our enemy animations function to play our enemy's animations if they are not attacking. Right. So physics process. Else timer equals 0, yes. If we are not attacking, then perform enemy animations. If you were to run your enemy scene from here, you might notice that the enemy will try to attack our player, but the problem is that they will try and attack our player even when they are turned away from our player. In our timeout function, we are setting the new direction for animation, but it is not updating our new direction accurately. To fix this, we will need to make sure that our new direction is set accurately during an attack, and that it is in sync with the direction the enemy is facing. For that, we will create a new function that syncs our new direction with the actual movement direction of our enemy. We will then call this function whenever the enemy moves or rotates. This will ensure that our new direction is accurately representing the direction the enemy is facing when it is attacking. Let us create a new function that will sync our new direction. You can do this above your timeout function. Yeah. Right. So copy paste the comment. Function sync new direction. If direction is not vector 20, new direction equals direction dot normalized. Then we'll call this standalone lambdas cannot be accessed. Consider assigning it to a variable. Hang on. Bar new direction is vector 201. Yes. Bar animation. Now where are we? New direction plus direction dot normalize. Direction is not vector 20. Then huh? Okay, I think I've done something wrong here. Because it's indented. There we go. That's probably why. Okay, everything's fine. Good. Where were we? Here we are. Then we'll call this function in the on timeout function, which is the place where the enemy starts its behavior. This ensures that whenever the enemy updates its behavior, it also updates its direction or animations accordingly. So here, chase radius, sync new. Oh okay. New direction equals direct player.distance dot normalized. Sync new direction. This is being called at the end of every instance, and surely it would be more prudent to just put it after the loop. Oh no, because if there's nothing happening when it's timing out, then there's no direction to sync. I don't know. Remember, your enemy will attack in the direction of your player's last known location when they started attacking, so it's natural if there was a delay in them turning towards the player. It's a new location when attacking. For example, if you're on their left when they started attacking and then you suddenly run to the right, they'll finish their attack animation towards the left first before redirecting to the right. Okay, troubleshooting. My enemy is stuck on idle. If you're noticing that your enemy moves only in the idle animation, you need to change your direction normalization value to something lower than 1, such as 0.7, because our enemy has a rotation vector and might not move precisely in a 1-1 vector scale. Okay. Stopped. Okay, doesn't seem to be moving. Okay, so if almost direction to Y is 0.7. It's been lower than 1. So why did I put it 0? Oh, whatever. 0.7. And this is minus 0.7. The page 2 divisible. Okay. Your full code should look like this. We go to Dusty Trails, script, enemy. Enemy animations. If direction is the new direction equals direction animated sprite walk. Yeah. Animation equals idle plus return direction and respectively play. Yeah, that animation's fine. Okay. Yeah, it's working. I guess why. I can't seem to. Wait a minute. Oh no, no, it doesn't buy updates when I'm playing. Okay, okay, let's go to part 11. This is it for now, as we will implement the attacking animations in the next few parts. In part 11, we will add our enemy spawner scene so that we don't have to manually instance X amount of enemies in our scene. Remember to save our game project, and I'll see you in the next part. Okie doke. That was a fairly short tutorial part. Let's go to spawning enemy, so part 11. So we're coming up to the halfway stage. Part 11, spawning enemy AI. Or cowboy emoji. Imagine how populated our main scene would be if we had to instance 50 plus enemy scene is on it. This not only looks clustered, but it also means that we will only have 50 enemies in our scene, and if we kill them all, they'd be gone until we reload the game. To fix this little conundrum, we can create an enemy spawner that would spawn our enemies at random locations throughout the map and at a constant value, meaning that we'll never have more or fewer enemies than we define. Each time an enemy is removed by us killing them, the spawner will spawn a new one, and so forth. We'll also make our spawner flexible enough so that we can change the spawn area and max enemies in the inspector panel. This means that we can instance, multiple spawners in our main scene to have X amount of enemies spawn in different areas. This sounds interesting. Well, what are you waiting for? Let's spawn some enemies. I haven't skipped the, no, I haven't skipped the shooting and looting part. So we will learn how to work with a timer node, how to create scene references, how to reference nodes in other scenes, how to reference tile map properties, and how to work with rectangle properties. Okay. First of all, let's remove all of the instances of the enemy scene from our main scene, because we're going to be spawning them in a different way. Let's see. Hang on. Enemy hasn't been changed. It is saved. Good. Wait, I am uber paranoid. Which were saved like that normally? Okay, delete. Yes. Let's create a new scene with a node 2D as its root. This will allow us to draw our enemy nodes onto our scene. Rename this node 2D as enemy spawner and save it under your scenes folder. Okay. Save scene under our scenes folder and we'll put it as enemy? No, enemy. Switch this whole thing. We'll need to add a timer node to the scene so that we can spawn an enemy every second unless we've reached our max enemy amount. Enable auto start because we want this timer to start as soon as our game starts. We can start spawning enemies. So add a timer. And auto start it. There we go. We'll also need to go back to our enemy scene and disable the timer there, because we don't want that enemy to start moving before the completes rolling, or start the timer later on in the code itself. So, enemy, disable auto start, there we go. Attach a script to your root node and save it under your scripts folder. Attach script. Enemy spawn, scripts, spawner. Yep. There we go. In this script, we'll need to define a few variables. These variables will randomize our enemy's spawn position, set and export the enemy min values, set and export the existing enemy's values, set and export the enemy's current spawn count, set a reference to our enemy scene, set a reference to our map's tile map properties so that our enemy doesn't spawn on certain layers, for example, our water and foliage. Hang on. So we got a load of code here. Right. So our tile map. Spawn variables that can be edited in the inspector panel. It's a okay. Export var spawn area. which is a rect2 equals rect2 gives 50 by 150, and dimensions are 700 by 700. Maximum amount of enemies that can spawn. Oh yes. Export bar max enemies equals 20. Enemy amount that will load up the game. Export bar existing enemies. I personally would call it start enemies, but whatever. Enemy count. Because you need no count. Learn to spell. Scene reference and randomizer. Or enemy spawn position. So bar enemy count equals 0. Bar enemy underscore scene equals preload res scenes enemy.tc. And that's an RNG. To spawn our enemies, we need to create a function that will spawn the existing enemies at the start of our game, and the rest of the enemies when the timer times out. We can call our function spawn enemy. In this function, we will create an instance of the reference to our enemy scene. When we create an instance of our scene, it saves this as a resource without loading it from the disk every time we call it. This saves space and time. In Godot 4, we instance a scene reference via the instantiate method. So now that we have an instance of our enemy scene, we can add our enemy as a child on our node hierarchy via the add child method. In simple terms, we're adding enemies from our enemy scene to our spawner scene tree. So, enemy spawn, oh yeah, enemy spawns, add child, enemy. If you think about it logically, you know that you cannot just spawn an enemy and in position one of our games spawns it underneath a building or in the water. We won't be able to get to the enemy, so to prevent this issue from happening, we have to create a function that will define the valid spawn positions for our enemy. Before your spawn enemy function, let's create a new function called valid spawn location, which takes a vector 2. It will have its position as its parameter because it is returning valid locations and positions based on the layers of our tile map. So for now it says just create a placeholder. Valid spawn location position, which is a vector 2. Now, depending on the layers that we added to our tile map, the next part might be different on your side than it is on mine. In the part where we added our map, we create the following layers: water, grass, sand, and foliage. Layers each have an ID assigned to each of them. We start at 0, so that water 0, grass 1, sand 2, foliage 3. We only want our enemy to spawn our grass or sand layers. Anywhere where our other layers are present, we do not want them to spawn. We can check for these layers by using the tile map's get layer name method. In our function, we will return the layer names for our grass and sand, since only those are valid spawn locations for our enemy. Okay. Ah, yes. So... bar, valid location... equals... tile map dot get layer name 1 or tile map dot get layer name 2. Yep. Why do these need to be in brackets? Whatever. If the two conditions are true, the position is valid. Return valid location. So really would be checking if not water or does it automatically return the topmost layer? We can check these layers by using get layer name. Return the tile map layer's name. Okay, that's not int layer. Where's... oh, whatever. We're going to return lanes for grass and lawn and sand too, so hang on, let me check if our tile maps are right. So our main scene... where are you, tile map? There you are. So our layers... it's grass, that's 1, and sand, that's 2. Guessing they're counting up in terms of ID. I think there should be a name to layer thing like they have in Unity, although whatever. Now that we have our valid spawn locations assigned, we can go back to our spawn enemy function to spawn our enemies in these valid locations. We need to create a boolean variable that will store our valid location. While this variable is false, we will check for a valid spawn location to spawn 2 and will return true if 1 has been found. Once our spawn location returns true, we shall spawn an enemy. You will see that I'm calling a function called spawn from our enemy scenes instance, but this function does not exist yet. We'll create it at the end as it only functions as an animation delayer. Right. So, add child enemy. Yep. Spawns enemies on these valid locations. Oh, no. So. Valid location. Is false. While not valid location. Keep looping to find a randomized spawn location on our thing. Then set a slide location to be the enemy's new position. Then spawn with animation delay. Okay. With our location this... Where's the position on here? Oh, whatever. With our location checking and spawning functions set up, we need to initialize our randomizer and our main scene's tilemap node reference for I don't know. Perhaps I'll get to it later. Enemies.spawn. Yeah, that's outside loop. With our location checking and spawning functions set up, we need to initialize our randomizer and our main scene's tilemap node reference for our layers checking in our ready function. So still in enemy spawner. Ready tilemap equals get tree root get node main map. There we go. And RNG will randomize it. Remember when we said that we needed to spawn enemies twice? Once when we load the game, add our existing enemies, which said should be 5, and then also throughout the game load the rest of the enemies until we reach our maximum amount of enemies, which should be 20. In our ready function, we can add a loop that will spawn our existing enemies every time the game loads. So there, yeah. Create starting enemies. 4 I in range. No, not range. Existing enemies. Spawn enemy. And enemy count equals count equals existing enemies. Yep. Next, we need to spawn the remaining enemies. We can do this in our time nodes timeout signal. Connect the signal to our scene root. Yep. Where you'll see if I'm contacting a timeout at the end of the script. We will add a conditional that will check if the enemy's count is lower than the max enemy count. If our current number of enemies is lower than our max amount of enemies, we will spawn more of them. We also then need to update our enemy count by our spawned enemy count. in our enemy scene, oh no, wait, you've got code here. So our on time timeout is if enemy count is less than our max enemies, we'll spawn an enemy and our enemy count plus equals 1. There we go. In our enemy scene, we can finally go and create a spawn function that we call in our enemy spawn function. This spawn function will disable our enemies' movement animation up until they've spawned so that they don't run around the map before spawning completely. I don't have a spawn animation to play on character spawn, so I'm just going to duplicate my damage animation and rename it as spawn and set the animations to still play when the enemy spawns. Rightio. So we go to enemy, animate sprite 2D, duplicate this one. Not the animate sprite 2D, but rather the animation in of itself. And there's no duplicate function. Here. Okay. Guess we're doing this the old-fashioned way. There's got to be a way to copy a frame and then paste. Oh, yes, there is. Yes, there is. Damage. They're the same. Copy frame. What is it? It's Control C, Control V. Oh. Okay. Easy as you like. Apparently I can't read what's on here. That's empty. Yeah, okay. We'll need to reset our... Sorry, we need to reset this is attacking variable back to pulse after starting the timer, so that's walk and other animations can play. So we also need to connect the animation finished signal from our animate sprite 2D node to our enemy script. Yep. So this is an enemy. Want to create a new enemy we need to create one new enemy every second until the enemy count is already equal to or greater than max enemies. Okay. So spawn animated sprite 2D dot animation. Technically the function should be called on spawn because it's not this function doesn't spawn. It doesn't actually spawn the enemy. It's just logic to do when it's spawned. So well, it's nothing major at all. So our on sprite to the animation sprite finished, whatever you want to call it. If our animated sprite 2D animation is spawn. Why does it automatically have the... I guess it's because we've got a spawn here and it's just thinking of that. I don't know. We want to start our timer. Okay. Never. Ah, yes. And then you're out of this if statement. Is attacking equals false. Same as the player. Our code shall now look like this. So I think our main thing was the enemy spawner and the enemy. Hang on, we'll look at enemy because it's closest. Explore fast speed 50. Bar direction, bar new direction, animation is attacking, RNG, timer, player, ready, player, randomize, movement, collision, timers, enemy animations, direction. Yeah, we need to add this. If our animated sprite 2D animation equals spawn. Then start our timer. And reset it. Wait, whoa. So put that there. Oh, so it should be in the wait, where's physics process? Oh yeah, here we go. Our sync new direction is somewhere else in code, but it's does say the same thing. On timer timeout. So where's return direction? That's at the very bottom. Okay. Okay, so the functions are a bit in the wrong order compared to this, but I think they all say the same thing. So there's no problems on this front. Animation play spawn sprite animation if the animation spawn. Oh. Hello? Okay, that's your encounter should look like this. If you create an instance of our enemy spawner in main, make sure you have no enemy scene in our main scene. Of course we don't. Transform, reset. There we go. Make sure you have no enemy scene in your main scene. You're running game will notice that enemy spawns. If you notice that so hang on, let's run it and then okay, yeah, it is stuck in the spawn animation. Bloody hell. Okay. If you notice that your enemy isn't chasing you, it's most probably because you changed the enemy spawner's no position. This position should always be set to 0, 0. Yep. You might be wondering, how do I get the most spawner in the top left corner of my game? Well, you need to change the XY position in the spawn area property in your inspector panel. Huh? Wait, what? Yeah. Okay, apparently the X and Y is a rectangular position. The width and height of rectangular width and height. I've also noticed that sometimes the animation physics does not emit properly because our elements stay idle. To fix this, we can fire off our timer start code in our physics process function. Okay, so that prompt in here. If this still does not work, and you're just remove it for now and start the timer directly. Control K for comments. So at the very bottom, that spawner goes, okay. Localize sprite. 2D animation finished. So this gets taken out. Right. Okay, let's see what's going on. They're still stuck. Oh. I don't know what's going on, but I feel I'll just copy and paste what it is in the how it is on GitHub. It's somewhat different, but nope, still stuck. God damn it! Now what? Manage by 2D sprite frames. Oh, it's looping. I say it's a loop. That's why. That might be. Yeah, that might be the problem. Let's try it now. There we go. It works. It just works. Okay. I'm gonna take a quick break. Then go back to this thing and oh yes, sorry. Where are we now? Yeah, we can get rid of all these. So part 12. Players shooting and dealing damage. I'm going to take a quick break and then I'll be right back. Okay, we're back. So we're now on part 12, shooting and dealing damage, cowboy emoji. So what good is an enemy if you can't shoot them? In this part we're going to create bullets that our player can shoot in the direction that they are facing. Then we're going to add an animation that will show that our enemy is being damaged if our bullet hits them. If the bullets hit them enough for their health value to run out, they will also die. Later on, we will up our player's XP and add loot to the enemy upon their death. But for now, let's buckle up because this part is going to be a long one. Okay. So, spawnable bullets. Let's start by creating the bullets that will spawn when our player shoots or attacks. This scene will be similar to our pickup scene structure. Create a new scene with an Area 2D node as its root. Rename this node as Bullet and save it under your scenes folder. Okie doke. So, scene with an so we don't want a node 2D, we want to change this to an Area 2D. And we'll call it Bullet. Okay. We need to use bullets and save it in the scenes folder. Okay. Scenes bullet capital B. It has one message, there's no shape. Let's add a collision shape 2D with rectangle shapes. We've done this song and dance a few times already. Rectangle shape, there we go. We also need to see our node or bullet. Our bullet will have an impact animation, so we need to add an animated sprite 2D node. Head sprite 2D, there we go. Add a new sprite frames resource to it in our inspector panel. And in your sprite frames pane below, let's add a new animation called Impact. The sprite sheet we will use for our bullet can be found under Assets FX defexplosion.ping. Assets FX defexplosion.ping. It's 1, 2, 3, 4, 5, 8 by 1. Only select the first 3 frames. Okay, there we go. Change the FPS value to 10 and looping off. We also need to add a timer node to our scene with autoplay enabled. This timer will emit a timeout signal when the bullet needs to self-destruct after it's not hit or impacted anything. Finally, we can add a script to scene and save it in the scripts folder. Okay, so let's put in a timer and a script on it. Timer and a script. In the scripts folder, bullet.good. There we go. Okay, now we can start talking about what our bullet scene needs to do. We first need to define a few variables which will set the bullet's speed, direction and damage. We also need to reference our tile map node again so that we can ignore the collision with certain layers such as our water, which has collisions added to it, but it shouldn't stop the bullet. So, adding the code. So bullet such so variables var tile map reference so our speed equals 80 var direction, which is a vector 2, and our damage, not danger. Let's initialize our tile map in the ready function just so that we can get it out of the way. Okie doke. Ready. Tile map equals get tree dot root dot get node. It's gotta be a shorthand for get tree dot root, given the amount of times I've done it. Oh well. Main dot slash map. Then we need to calculate the position of our bullet after it's been shot. This position should be recalculated for each frame in case our player moves. Therefore, we can calculate it in our built-in process function so that it updates its direction during each frame movement. We can calculate this position by adding its current position by its direction multiplied by its speed at the current frame captured as delta. So, function process. Yeah. Position plus speed by delta by direction. Your usual, yeah, position plus speed. So it does do bid mass, right? When we did our pickups, we connected the Area 2D's body entered signal to our scene to add the pickups to our player's inventory. We wanted to do the same for our bullet scene, but this time we check the body entered is our enemy so that we can injure them. We also want to check if the body entering our bullet's collision is the player or water layer from our tile map, because we want to ignore these collisions. Connect the body entered signal to our bullet scripts. That would be... no, bullet. There. Node area 2D body entered. Connect from body and receiver on body entered. Yep. Inside this new function, let's accomplish the objectives we set above. So here's our code. On body entered. So ignore collisions with player. Okay, not sure why. If body.name is player, we return. If body.name is map, if tile map get layer name is 0, then return. Tile map not get layer name 0. Okay, still not sure how these tile maps actually work. It's like we give. It's like we're passing in body or whatever sort of invisibly. I don't know. It's a bit weird. It just feels a bit wrong, you know, not passing anything to tile map. If body name find enemy is greater than or equal to 0. Wait, what? Okay, to do add damage hit. Pass on here. We cannot damage the enemy yet because they do not have any health variables or functions set up. We shall do that in a minute, but for now, let's stop the bullet from moving and change its animation to impact if it does not hit anything. We're doing this because we don't want a random bullet just floating around in our scene. Okay. Direction equals vector to 0, and we play our impact animation. We also need to delete the bullet from the scene after removing and stop the impact animation. We've done this before in our pickup scene. Let's go ahead and connect our animation 2D animation signal to the bullet script. Signals, not well, animation finished, which is no, it's on here. Connected to bullets, yep. So our code says okay, if our animated sprite 2D animation equals impact get tree q delete self. Yeah, it's connected. So finally, in the bullet scene, connect the timer node's timeout to our bullet. We want this function to also play the impact animation if it's to not hit anything after 2 seconds, please. Because playing this animation will trigger the animation finish signal, which will delete the bullet from our scene. Right. So I'm going to just copy paste this line. Put it here. There we go. Don't forget to change your timer node's wait time to 2. So that it plays the animation after 2 seconds and not 1. For now, we are done with our bullet scene. Seems to have our bullet scene animation set up, and okay, we're still in our bullet scene. Since our bullet animation and movement animation plus the bullet's ability to remove the bullet from the scene, we need to go back to our player scene so that we can fire off bullets via our UI attack input. In our player script, let's define some variables that would set the bullet damage, reload time, and the bullet fired time. We also need to create an instance of our bullet scene so we can spawn it at our player's front when they shoot. Here's our code. So we go to player. Just put it underneath the we'll pretend those debugger errors aren't there. So underneath stamina pickup, then bar bullet damage equals 30. Bar bullet reload time equals 1000. Bar rounds per second equals 0.5, and our bullet scene is preload our bullet scene. By putting bullet, would it? It does. Now that we can change our UI attack input to spawn bullets, calculate the reload and remove ammo. When we spawn these bullets, we need to take into consideration the time the bullet was fired versus the reload time. We want our player to take a 1000 milliseconds break before being able to fire off the next round. To get the time in Godot, we can use the time object. The time singleton allows for converting time between various formats and also getting time information from the system. We will use the method getTixMsec for precise time calculation. First, we will need to check if our current time is bigger than or equal to our bullet fire time, and if we have ammo to shoot, make sure to assign it to my player first. If it's bigger, that means we can fire off a round. We will then return to our isAttacking boolean as true and play our shooting animation. We will update our bullet fire time by adding our reload time to our current time. This means our player will have a 1000 millisecond pause before they fire off the next round. Finally, we will update our ammo pickup amount. And here's our code. So, player. Function input. Here we are. This is our UI attack. If event is action press UI attack. Right. Bar now equals time dot get tixmsec. Ooh, there's a usec there for microseconds. If now is less than, so greater than or equal to bullet fire time. And ammo pickup is greater than 0. Then we play our animation. And if our bullet fire time is not... Bullet fire time is not declared in current scope. Whatever. So that's our code there. Bullet fire time equals now plus bullet reload time. Ammo pickup equals ammo pickup -1. Ammo pickup's updated. Pickup. Okay, so this bullet fire time doesn't seem to have been put in, or I might have completely forgot it. I don't know. Hang on, we'll control F this thing. No, that seems to be. Oh, we'll I'm thinking it probably should be spawned underneath here, and the author forgot to put it in, but here we go. Your final character look like this, and then we so our player script. Bullet fire time. There's a bullet fire time there, and there's no rounds per second. What? Wait, so they put... Oh, okay, I think they must have named that something else. I'm guessing? Yeah, because this is the only place where rounds per second is mentioned, so rounds per second should instead be bullet fire time. There we go. If it's bigger, that means we can fire from... First, if I check if... Yes, been there. Spawn our bullet in Funk on animated spot to the animation finished function, because only after the shooting animation is played do we want our bullet to be added to our main scene. We have to create another instance of our bullet scene where we will update its damage, direction, position as the direction the player was facing when they fired off the round, and the position 4 to 5 pixels in front of the player. You don't want the bullet to come from inside the player, but instead from the gun's quote-unquote barrel. We can also have the player shoot in the direction that our mouse is pointing at instead of the direction that our player is facing. So just let me know if you want me to show you how to implement that. Actually, I'll probably wait till the end. Right, where are we? Ah, here we go. Is attacking false, and then we add in. This is in player, yes. Instantiate bullet. So if our animate sprite 2D animation begins with so that's what we put it attack side and not side attack. Bullet equals bullet scene instantiate. Bullet dot damage is bullet damage. Bullet direction equals new underscore direction dot normalized. Place it between 4 and 5 pixels away. So bullet position equals our position plus new direction dot normalized. I don't know why we can't just plonk in the bullet dot direction, but whatever. Position plus new is by 4. Get tree. Root. Get node. main. Add child. The bullet. Now if you run your scene, a bullet should spawn after you press Control to fire your way attacking bar. It's a bit big for a bullet. Let's change its size. Let's run it first. Ooh. It's not shooting. What seems to be the problem here now? Yeah, now it's just not shooting at all. It's is this under the troubleshooting or what? No, there's a we're all the way up here. Well, it should spawn after you press Control to fire UI attacking bot. You might attack, yes. Oh, now get TXM set. Now is greater than blue fire time and ammo. Oh, that might be it. I don't have ammo. I think. Yes, that's correct. I don't have ammo. So. There we go. Okay, so the... Yes, okay, so... The code here initializes us to have 12 rounds at the beginning. See? Right. So, in our bullet scene with our animated spread to let's just change its scale value from 1 to 0.4. Reload. Oh. That was our player. Whoops. Not our player scene, but instead our bullet scene. There we go. Now if we do run it, if we run it again, I mean it is a bit sluggish, but right then. Oh crap, and Nora. Of course it kicks us to the start, because why wouldn't it? Also, add that full frame of the bullet FX to our impact animation. Sorry for the inconvenience of that. I'm getting out. I just thought it looked better at the last minute. Then get back in and change your bloody... Whatever. You're not exactly writing this by the seat of your pants now, are you? Probably just... There we go. Now if you're in a scene, your bullet should be much smaller and should also self-destruct after 2 seconds when it hits another collision body. Now we need to add the functionality for our enemy to be damaged by a bullet impact. Enemy damage. Back in our bullet script, I added a to-do since we still do not have a damage function or health variable set up in our enemy scene. We will do that now. In your enemy script, let's set up its health variables. Just like the player, we need variables to store the health, max health, and health regen, as well as a signal to fire off when it dies. We will calculate its health regeneration in its process delta function since we want to calculate it each frame. We've already calculated this in the player script when we did its updated health value. So, enemy. Let's see how far we're coming up to 3 hours. Yeah, we'll probably make this the last section, part 12. I might stream again after tea, I'm not sure. Where are we? Oh yes, enemy. Custom signals, where are you? Okay. I wonder if that's a way to put a sort of a region. Well, I suppose this editor is bare bones. I'll see if I can use Visual Studio Code. Hell equals 100. Max health equals also equals 100. Health equals 1. We will calculate its health regen in its process delta. Since we've come to calculate each frame, we will calculate in the player's script when it's its health value. Process, not physics process, just regular process. Function underscore process delta, yeah. Health equals min of health plus health regen. By delta. Max health. Okay. Let's go ahead and start creating our damage function. This will be a function that we call in our player and bullet scenes to damage the enemy upon bullet or attack impact. Before we can do that, we also... Sorry. We also need to... This will be the function we call to damage them, but before we do that, we also need to give the enemy some attack variables. Before we do that, we also need attack variables. We can copy over the attack variables from our player script. Okie doke. So this is bullet damage to, yep. So I was right about the bullet fire time. On. The damage function will decrease our enemy's health for the bullet damage passed in by the player or attacker. If their health is more than 0, the enemy will be damaged. If it's less than or equal to 0, the enemy will die. Okay. So we'll want about... Function hit damage health. Oh, so you can do minus equals instead of that equals that. Health equals health minus damage. If health is greater than 0, pass. Else. Pass. We will slowly, slowly make our way to completing our damage function. So let's get started by adding an animation that would indicate that our enemy has been hit. For this, we can change the enemy's modulate value via the animation player node. The modulate value refers to the node's color, so in simple terms, we use the animation player to briefly turn our enemy's color red so that we can see that they are damaged. You will use this animation player node whenever you need to animate non-sprite items such as labels or colors. Let's add this node to our enemy scene. So we need to have an enemy scene, enemy child, animation player. Don't know why it's so still on the editor so unresponsive. Okay, animation, here we go. We add animations to the animation player node in the animations panel at the bottom of the editor. To add an animation, click the animation there and say new. Let's call this new animation damage. I just can't spell the word damage today. Your new animation will have a length of 1 assigned to it. As you can see, the values run from 0 to 1. Let's change this length to 0.2. Wait, what? There we go. 0.2. Oh, no. Huh? Oh, here's your... Oh, of course. I was looking in the wrong place. Let's change this to 0.2 because we want this damage indicator to be very short. You can zoom in out on the track by holding down Control and zooming with your mouse wheel. Whee! We want this animation to briefly change our animated sprite 2D nodes. Modulate, or color value, which is a property that we can change in the node's inspector panel. Therefore, we need to add a new property track. Click on add track and select property track. Connect this track to our animated sprite 2D node. Next, we need to choose the property of the node. We want the modulate value, so choose the mod. There we go, modulate. Okay, very Blender. Now that we have the property we want to change, we need to insert keys into the track. This will be the animation keyframes, which define the starting and or ending points of our animation. Let's insert 2 keys, one on our 0 value and one on our 0.2. To insert a key, just right click on the track and select insert key. If you click on the cubes or keys, the inspector panel will open and you will see that you can change the modulate value of our node at the frame underneath the value. We want our modulate value to go from red at keyframe 0 to white at keyframe 1. So time equals 0, and then oh, I get you now. Okay. Red at keyframe 0. Where? Other way. There we go. To make our modulate value red, just change it to 2.50. Way ahead of you. You also want to change the track rate of our animation. If you were to run the animation now, the modulate color will gradually change from red to white. Instead, want to change instantly from red to white when the 0.2 keyframe value is reached. To do this, we can change this track weight, which is found next to our track under the curved white line. This. We need to change our track rate from continuous to discrete. Go to a 3 options for track rate. Update the property on each frame, only update the properties on keyframes, or only update the properties on keyframes or triggers. So we need to change our from to run the animation down the modulator. We need to change our track rate from continuous to discrete. It should look like this. So continuous, discrete. There we go. Now, if you run this animation, it should briefly change your enemy sprite color to red and then back to its default color. There we go. We can go back to our damage function, now play this animation if the enemy gets damaged. Back to scripts. Function hit damage if health equals is greater than 0. Animation player dot play damage. Let's go back to our to-do in our bullet script. This bullet, not that bullet. And replace it with the damage function we've created. So we have our to-do here. Body dot hit for damage. Stop the movements and expose. Lastly, for this section, we need to add the functionality for our enemy to die. We've already created our signal for this, so now we just need to update our existing code in the enemy script to play our death animation and remove the enemy from the scene tree, as well as update our enemy spawner code to connect to this signal and update our enemy count. Let's start in our enemy script underneath our death conditional. When our enemy dies, the first thing we do is stop the timer that handles its movement and direction. We also need to stop our process function from regenerating our enemy's health value, so we'll set the set process value to false. We also need to set our is attacking Gale equal to true so that we can trigger our animation finish signal so that we can remove our node from our scene after our death animation plays. We simply want our enemy to stop, play its death animation, and then signal that it has died so that a new enemy can spawn. Okay, so here's our code. So we put it to enemy hit if health is that, else death. So timer stop. Direction equals vector to 0. Don't want it to move. Stop its health regen, set process to false. So I'm guessing this means that this thing here isn't going to be called if it's false. Alright. Is attacking is true. And finally, animated sprite 2D. Play. Death. And death dot meet. Right then. All what I have to do here is remove the enemy from the scene after their death animation has played. So here we add another if animated sprite 2D dot animation equals def get tree q delete self, and then yeah, it's attacking is false. Now we need to go to our enemy spawner script to create a function that will remove a point for our enemy count after the death signal from our enemy script has been emitted. So enemy spawner on enemy death, we so func on there's a underscore on underscore enemy underscore death enemy count minus equals 1. Well, no, it puts it as the enemy count minus 1. We want this function to be connected to our signal in our spawn function so that our spawner knows that an enemy has been removed and it should spawn a new one. So, yes, here we go. So we don't do it from the inspector, we do it from code. Okay. Yeah, of course. Underscore on enemy death. Yeah, we do it from code instead of from the inspector. Because I mean, if I was running it in C#, I'd probably make on enemy death a static thing and then connect this to its static class, but we're not doing Unity, so yeah. Our final code should look like this. And so our player can now shoot a bullet, and if it hits an enemy, it damages them after 3 hits, it kills the enemy and removes them from the scene. Well, let's see if that happens. One, two. Okay, it's not being hit. Okay. Troubleshooting my enemy's death animation doesn't play. If you notice that you're. Huh? Let's. Find enemies, their body dot hit damage. Okay, Okay, so it's not getting cold. It's not getting cold. Okay, that's odd. So body name find enemies. That's then enemy, yes. Okay. Okay. Got hit player. Okay. Return. It's just not getting cold, which is odd. Okay, find out what it actually is hitting. Hits the player. Hits character body 2D at 11. That's not enemy. What? Character body 2D at 11. Huh? Enemies. It is taking enemy, right? Enemy spawner. Enemy scene is enemy.tc. The route is called enemy. So, what's going on? It works for player. So, yeah. And if the enemy gets spawned, then the scene goes to... What the hell is going on? Body name find enemy, but there isn't an enemy in there. So hang on, enemy spawner. We'll try that. Let's have a look at what's happening with the enemy spawner. Let's see. Enemy scene, preload. Yes. Main map. Yes. RNG randomized. Yes. Spawn enemy. Yes. Add child. Enemy def connect on enemy def. Enemy.spawn. Enemy spawn is taking time to start. Maybe ready? Player equals that. RNG random. Doesn't seem to be anything different here. Huh. We collect your player map. But if we shoot at the enemy, it's not called enemy, it's called character body 2D. Let's see if there's a comment on this. My enemy's death animation, my enemy's comment. Tick to not count enemy animation does not work. That hasn't got a reply. Hang on, let me do a bit of Googling. I'll be right back. Godot engine. Instantiated scene name. Classify the instance scene by its name. I want to. It doesn't work for instance scenes even if I placed in stream the instance was possibly a bug who wants to ask me for issues by node by name. Try to use remote inspector to see what the scene tree actually made. Remote inspector, what the hell's that? Instancing scenes. Load, preload, yes. Instantiate. Okay. How to get name of node of instance scene. Get base name on stream but only type of pirate name. The fuck? Okay, so spawn enemy, where are ya? Creates an animation delay, animates for 2D play. Oh no, we're an enemy, not enemy spawner. Spawn enemy. Enemy scene, instantiate. Add child, enemy def connect. Print enemy dot name. Okay, so there's one thing that's getting instantiate name enemy, but everything else is being called character body 2D. What the earth is going on here? Hang on. Godot engine. Instantiate scene with name. Naming instance scenes. No instances, but the instantiate. Packed scene.instantiate. Node instantiate gen edit state triggers a gen edit state. Is this it? Instance. No. You're trying to print the row reference. Trying to print means to stop name. Also, you can set the name property directly. Huh? Okay, so it seems that the hang on, go to enemy spawner. Where are you? So get rid of this. So it seems that while we've instantiated our enemy with a random child, but for some reason you're not allowed to have something with the same thing, so therefore okay. So these are character body 2Ds. These are sort of generated names, but they're not. Enemy dot name equals. We'll call it enemy plus a count. Now that's going to introduce a bug later because enemy count isn't a okay. The enemy count goes minus. Enemy name. For total enemies. Equals 0. So when we add our enemy count, our total enemies will be have one added to them, and then total enemies plus str total enemies. So now if we do, okay, now let's try it. Oh, I forgot to type the print thing. Okay, print enemy dot name Right. So we open this. Should be enemy 0, enemy 1, enemy 5, enemy 6, enemy 7, enemy 8, enemy 9, enemy 10. Shoot this one. Okay, that death animation was a bit. 1, 2, 3. It's supposed to do that? Okay, so that's a bit of a hack. But it has fixed the problem. That's okay. That's been a bit of a while, so I'm going to take a break. Actually, no. I'm going to end the stream for now. Take a hour or so break, and then maybe stream again later tonight, or maybe not. So if I don't see you then, I'll see you. No, if I don't see you in a few hours, I hope you have a wonderful rest of the afternoon, evening, morning, and I shall see you soon.